Today we're going to talk about Chapter 5, Multiple Table Queries. These are the objectives. You can read over those when you have time. This talks about querying multiple tables. Retrieve data from two or more tables. You can join them. Use the same command as for a single table query. You select clause. You list all columns to display the from clause. List all the tables involved. Where clause, where you restrict the rows. And here's an example from customer, comma, rep. Here's the main thing you got to make sure you include. You have to tie them together by a field name. Like where customer.repnum equals rep.repnum. So both of those tables have a repnum in there, and that's how you tie them together. The most common mistake in this chapter for students is they don't tie them together. So if I say from customer, comma, rep, comma, employee, I would have an and tie the rep and employee together. So if I'm tying four tables together, I've got a where clause with three different equal signs, tie them together. All right. Also, I may have other ands, like and sex equals F or whatever. But make sure you tie the tables together. It does a good job in the chapter explaining this. And this is what I was talking about. It ties the table together right there on the where clause, and then they have an and credit limit equals 7,500. All right, then they got order line and item number, or item, I should say. They tie them by item number. Now, let me explain this. The field names don't have to be exact. Like it could say item num right here, and then the other table could be item number, as long as they have the same attribute, which means the same data type and size. Comparing joins, ends, and exist. Can join tables using the where clause and the end operator with a subquery, or exist operator with a subquery. And that's the hardest thing you got to figure out how to do in this chapter. It's when do I need to use the where clause with an end or with an exist, or when can I just put the tables on the from clause and tie them together? And unfortunately, the only thing that's going to help you with that is practice. And when you do it, when you execute your query, you look at the data and test it to see if it's correct. All right, so here's an example on the where clause, kind of like we've already shown, but they said and order num equals 51623. If you forget to put this order line dot item num equals item dot item num and by not tying together, it won't give you an error. It just won't give you the correct results. All right, here's using the subquery. Now, let me explain the way the subquery works. It executes the subquery first. So it's going to select the item number from the order line table where the order num equals 51623. It's going to build a temporary data table, and it's going to go up here to this select and compare every record in this select against the order numbers that came from this subquery. So just remember, it does the subqueries first and then does the outer query. Here's exist. Select order num, order date from orders where exists. Select asterisk from this. So it's going to build a data set here and check every record there. Correlated subqueries were queries about table listed in the outer query. This 5.7, it's order table listed in from clause the outer query. We've talked kind of about that. Must qualify order number column in the subquery because it's in both tables. And to qualify it, they got orders dot order num and order line dot order num. All right, so you want to make sure that you do that. Tell it which table the order num's from. Using a subquery within a subquery. It does the innermost and works its way out to the outermost. And so it'll do this one right here first, checking the storehouse equals 3. Then it'll take that data set and run against this other inner query right here, which I call intermediate, and then go to the outer. And again, it's just practice. If all your fields are in a table, two different tables, and you can tie the tables together, then you can do it on the from clause. But sometimes you may have to, like compare it against the average of a bunch of records, then you have to have a subquery. Order of evaluating queries. It does the innermost first and then intermediate and so on. Told you that multiple times. All right, let's talk about this example here. All of it looks the same that you've used before, right? You used the group by, the having, the order by in chapter 4. The only difference is you're just tying two tables together. So it's just one line up on the where. You'd have a where clause, and they just add that line right there, tying the two tables together. The rest of this stuff, works the same way. I want to point out this as. We talked about that in chapter 4. But it says num order times quoted price as order total. That's computed column. So, you want to go down here and say sum order total. It will not let you do that. It will crash. You have to do the calculation over again. So make sure you can't, if you said sum order total, it ain't going to give you the right results if it doesn't crash. It's just going to be wrong. So make sure anytime you do a computed column and you put it on a where or having clause, you have to do it again, computing again. An alias, we talked about the as to give it a column heading, but the alias is where you can give the tables a heading. For instance, they got from rep and change it to R and customer to C. That saves you a little bit on the where clause. Instead of typing rep, they can do an R. Instead of typing customer, they just do a C. That's very good practice. That's what most of us do in the industry. We do those aliases because it's just less typing. And you say, well, people type fast. Well, but sometimes you may have a typo. There's a lot less chance of me messing up typing a C for customer than spelling out customer. Self-joining a table. You just use the same table on the from clause. You just give it a different alias. And you used to compare records in one table. You treat one table as two separate tables because of the alias. Where F city equal to S city. See, what happens, the reason you have to do it the same table is because you got the customer number for the customer and the customer name, but you also want the customer number and the customer name, of the matching record that ties them together. Okay. And that's why you have to do an alias. Or another example would be like if you had a rep number in the customer table and you want their name of the rep, then there's not a name in the rep table. It's in the customer table. So you have to tie the customers together, and then you just make that the rep name. That's where you get the rep name. You can create a self join that divides the primary key of a table. This table twice in the from clause is alias. It's talking like this. This is about manager. From employee to employee, where E manager num employee num equals M manager employee num, and that's to get the employee name and their manager name. And notice I gave aliases over here. A column head as manager num. If you don't, it would just put employee num twice. So you need to, looks better that way, right? Joining several tables, what I was talking about earlier, same thing. This is joining 4 tables, and notice there's 3 where conditions tying those tables together. You say, I'm not sure how to find out what tables I can join together. If they have matching fields and you need information for both those tables, then you need to join them together. This is by far the hardest chapter you're going to have, as far as people get confused and stuff. The rest of the semester, most students don't have much trouble on it at all. All right, you select clause, list of columns, done that from list all the tables. Talked about all that. Take one pair at a time, indicate on the where. Just do it by an and. Talked about all this stuff. A union. The union of 2 tables is a table containing every row that is in either the first table, the second table, or both. They must be union compatible. That is, have the same number of columns with the identical data types and length. And so they're tying the customer table where rep number is 15. They're unioning that with the customer table and orders where the 2 customer numbers match on each of them. So what this is kind of doing is it's getting customers that have a rep number 15 or customers that have orders. Okay, that's what it's doing. Intersection. It's the intersection of two tables containing all rows that are in both tables. So that means they got the same row in both tables. Not supported by Microsoft Access. We don't care because we're not using that. So only thing that would show here is records, the same record in both tables. Difference. Two tables contain the set of all rows that are in the first table, but not in the second table. You use the minus to get difference. So those are, it's 502, 713, and 893 is the only rows that's in the first table, but not in the second table. Okay. Again, that's what it says, first table, but not in the second table. All or any. Condition is true only if it satisfies all values, any if it satisfies any value. That's kind of similar to and and or, right? And look how that works. It says, select customer number, name, balance, rep number from customer balance is greater than all the balances of customers that has the rep number 30. All of them, which means all of these have a balance greater than every customer that has a rep number of 30. Any, which means any of them. Any of them that has a balance greater than any of these rep 30s. That's the difference between any and all. You have self joins, inner joins, outer join, and products. Inner joins compares the tables from the from clause and lists only those rows that satisfies condition in the where clause. That's the inner join. That's kind of the same as doing what you're doing by tying the two tables together on the from clause. That emulates an inner join. So you could just as easily come right here and said from customer, okay, comma orders, where customer number equals order customer number, order by that. You get the exact same results. That's what an inner join does. Outer join, you have different types. You have a left outer join, a right outer join, and a full. Left outer joins for all rows from the table on the left side, which is the table listed first, will be included, and only matching rows to the table to the right will be included. Right is just the opposite. All rows from the table on the right will be included, and only matching rows of which is on the left. Full, it's all records from both tables. And again, the hardest part you're going to have to determine which ones you need to use. And in some of the examples on the lab sheet, it gives you a hint on like, hey, use a left join, or, but doesn't on all of them. The product of the two tables is a combination of all rows in the first table and all rows in the second. Omit the where clause to form a product. That's the summary, and I know I breezed right through it, but as always, nothing makes sense. You have any questions, you contact me and we'll talk about it, or I can even set up a WebEx, if you need to show you how to do it and stuff. You get 2 weeks to do this. It may take you all 2 weeks, some of you, because this is the hardest one. If you turn it in and you've missed a bunch of them, I'll give you a 0 and tell you to double check it. You've missed quite a few. There's no need me giving you a 60 and you not understand it. So I'll give you that second chance. I hope this helps. You have a great day.